Hi everybody, today we are on page 36 and we are talking about the difference of squares. This page is a little bit of, you can work it out without memorizing it, but if you do memorize it, it makes things a little bit easier. Let's start with the warm-up problems at the top. If we're going to multiply x plus 4 times x minus 4, you could do that in a box if you like the box method, or you can just double distribute it. Either way, you're going to get x squared minus 4x plus 4x minus 16. Or if you did it in the box, you get x squared here, 4x here, negative 4x over here, and a negative 16 here. Now, when we combine our like terms, these are our like terms, and when we combine those, they add up to 0. Negative 4x plus 4x is a 0, so we're going to get x squared minus 16. You're going to start seeing a pattern here. So let's try number 2. Same thing. If you want to set it up in a box, you can, or you can just multiply it out in a line. Either way. So if I multiply this out, I'm going to get 25m squared minus 5m, oops, that's an m, plus 5m minus 1. And once again, when we look at our like terms, negative 5m plus 5m adds up to 0. So this answer is just 25m squared minus 1. Let's do the last one. We're going to get 9x squared plus 6x minus 6x minus 4. And once again, we look at our like terms, and they add up to 0. So it's just 9x squared minus 4. Let's just take a second to look at what we've just did and how this is what's going on. So notice in the beginning problems, they are all like the first parentheses and the second parentheses are kind of the same. It's just one has a plus, one has a minus. Same thing here. The first parentheses and the second parentheses will have a 5m and a 1, but this one has a plus, this one has a minus. Same thing on the last one. We have a 3x and a 2. The first one has a minus, the second one has a plus. So our pattern is anytime we have a plus and a minus, or a minus and a plus, but the rest of the numbers are all the same, this is what's going to happen. What happens is those middle two terms add up to 0, and they drop off the answer. So it looks like a lot of the ones we normally have, and the answer is a trinomial, but here all we have is a binomial. And on our binomial, look, it's a perfect square, and a minus sign. A perfect square, and a minus sign. A perfect square, and a minus sign. The word difference, that means subtraction, right? So it says difference of squares, that means a perfect square minus a perfect square. Perfect square minus perfect square. That is a difference of squares. Okay, remember I said that if you can memorize some things, it'll make your job a little bit easier. So here we have a list of perfect squares. If you can memorize these, it's going to make your job a little bit easier. You don't have to memorize them. We've worked with them a little bit before, but just kind of have them in your mind somehow of, something easy to access for you. Okay, steps. First, make sure you have an actual difference of squares. Subtraction, and you can square root both. And then back to our rule. If you can memorize this rule, it's not a very hard rule, but if you can memorize this rule, it will make your job a little bit easier. When we are going to factor it, remember factoring is going backwards. So if we were going to factor this, we would go backwards to that. So we're going to take the square root of a squared minus the square root of b squared, and we're going to multiply that by the square root of a squared plus the square root of b squared. That seems really confusing, so let's look at some examples. All right, what's the square root of a squared? It's a. What's the square root of 4? It's 2. So my answer is a minus 2 times a plus 2. Let's look at the next one. Square root of n squared is n. Square root of 64 is 8. So we have n minus 8, n plus 8. Now, if this doesn't work, like you are stuck on something else and you just can't get it, You could also think of this as a 0x in the middle. And the factors of negative 64 that add up to 0 are negative 8 and positive 8, which is what we have here. So that's just another way to think about it. Number 3, it is a minus sign, so that's good. It is a perfect square and a perfect square. Square root of 81 is 9. Square root of x squared is x. So it's 9 minus x and 9 plus x. One of them's minus, one of them's plus. All right, let's look at number 5. Number 5, square root of 9x squared is 3x. Square root of 100 is 10. So it's 3x minus 10 and 3x plus 10. Remember, we can always check it by multiplying it out. So we get 9x squared plus 30x minus 30x minus 100. And those two middle terms do add up to 0, so we get 9x squared minus 100, and 9x squared minus 100 is what we started with, so we did it correctly. Let's try number 6. Square root both of these. Try this on your own for a second. Will you square root both of these and tell me what you get? So we're going to take the square root of each. We get 5y minus 7 and 5y plus 7. All right, I want to take a look at a trick problem, and that is number 8. This is not possible. Cannot be factored. Why not? Because it's a plus. It's supposed to be a minus. This one threw us off and gave us a plus instead, so that's not possible. Let's look at the next page where we put it together with a GCF. Anytime you're doing any kind of factoring, look for the GCF first. So on number 1, I see I have a GCF of 2. If I factor out my 2, I get n squared minus 36. Now, think about your perfect squares. Is 36 a perfect square? Yes, it is. So the square root of 36 is 6. So I'm going to keep my 2. I'm going to say n plus 6 and n minus 6. And that's my final answer. Let's look at the next one. Oh boy, I need a GCF. GCF of 2. So I'm going to have a 2 on the outside. 9x squared minus 25. Is 9 a perfect square? Yes. Is 25 a perfect square? Yes. Do we have a minus in the middle? Yes. So we are ready to factor it. Square root of 9 is 3. Square root of 25 is 5. One of them needs to be plus, one of them needs to be minus. I'm done. Number 3. You should see something wrong with number 3. If we divide by 3, we get 3 times a squared plus, oh boy, 49, I think? Yeah, 49. Can this be factored? No, it cannot. That's my final answer because it's a plus instead of a minus. Remember, we cannot do this if this is a plus in the middle. That has to be a minus. On the other two, they do work because they had a minus, and so that's my final answer there, and this is my final answer here. All right, a couple more problems. We don't have to do all of them. Let's do number 5. I was looking for the hardest one. I don't know, maybe number 6. First of all, yikes, is there a GCF there? Man, yikes. I'm not even sure if there's a GCF, but you know what? I know that they're both perfect squares. So I know I can say 12a plus 7 and 12a minus 7. There was no GCF, but they're both pretty big, and that gave us the perfect squares here. Let's go ahead and look at number 5. There is a GCF. I know 2 can go in, but I think that's as high as we can go. So 2 is going to go in here, 16a squared minus 9. 16 is a perfect square, 9 is a perfect square, so 4a plus 3, 4a minus 3. Remember, every time we're just taking the square root, and as long as it's a minus sign, that can be my final answer. Okay, that is all for the notes for today. Now you'll have a worksheet to work on from here.